So welcome back friends, welcome in another video tutorial. So in this video tutorial we will going to talk about on Eadie Hofstee diagram or Wolf-Eadie Augustinson Hofstee or Eadie Augustinson plot. So this is another approach to graphically represent the Michaelis-Menten equation. Okay, or in another words, it is another approach to linearize the Michaelis-Menten equation in graph. Okay, so in the Lineweaver-Bach plot, we have discussed that there was a disadvantage. That is, Lineweaver-Bach plot will distort the error structure of the data. Right? So here, this Eadie-Hofstee diagram is robust for those error-prone data. Okay, so there is nothing huge difference between Eadie-Hofstee diagram and Lineweaver-Bach plot. Both are the linear approach of Michaelis-Menten equation. So again, our first goal will be to convert V0 is equal to Vmax into S by Km plus S into a equation that will give the sense of y is equal to mx plus c. Okay, and obviously it will not be the previous equation that we have discussed in case of Lineweaver-Bach plot. So it will be quite different. So let's see how. First of all, we have taken the inverse of the v0, that is 1 by v0, and also the inverse of what is present on the right side. Okay, now we have multiplied Vmax in both the side. Okay, then Vmax cancelled out. After that we have written V0 here, right, that we can easily do. Then we have multiplied V0 with Km and V0 with substrate concentration. Okay, now after that we have simplified and we have taken V0 on the left side. Okay, now it giving us a sense of y is equal to mx plus c, where m is km and x is v0 by s and c is vmax and y is here your v0. Okay, so now we will going to draw the diagram or draw the graph. So here the graph is this one, and here as there is a minus sign in m, that is why the graph is this type. Okay, and here the intercept for y-axis is vmax, and now slope, that is the value of m, here is minus km. Okay, now in the previous video one thing I have forgotten to mention, that is how you can calculate the intercept of x. You can calculate easily by taking y is equal to 0. Okay, so you will get x is equal to minus c by m. So then by putting the value of c, that is vmax, and value of m, that is km, you can get your answer. Similarly, you can do this in case of your Lineweaver-Bach equation also. Okay, so this is the graph. Here v0 will be in your y-axis and v0 by substrate concentration will be in your x-axis. Okay, now let's see the use of Eadie-Hofstee plot. So like other techniques like your Lineweaver-Bach plot, Eadie-Hofstee plot can allow us to find out some important kinetic terms rapidly. For example Km, for example Vmax. Okay, and the advantage is obviously it is more robust against error-prone data than the Lineweaver-Bach plot. Why? Because it gives equal weight to data points in any range of substrate concentration or reaction velocity. On the other hand, the Lineweaver-Bach plot unevenly weighs such points. Okay, so you can remember this. And there is also a drawback, that is neither ordinate or neither abscissa are independent variables, and we have seen this because both the y-axis and both the x-axis are dependent on the reaction velocity, right? So any kind of error in the experiment can reflect itself in both the y-axis and x-axis. So that is a drawback in case of Eadie Hofstee plot. So we have to perform the experiment very well to avoid those kind of experimental errors. Okay, so that was the last video for enzyme kinetics theoretically. After that, we will going to talk about some MCQ question on upcoming videos of enzyme kinetics. So till then, bye bye.